Right. So before I start with the proportion, just recall what are the stuffs we have seen for the proportion. So today we will see the problems on proportions. Then we will see the difference of mean, and then we will see the problems on difference of proportions. Okay, there's three categories we will going to discuss today. So in the proportions, the formula which we're going to apply is that mean of the proportion will be exactly equal to the proportion, all right, and the standard deviation of the proportion will be equal to square root of pq by n, where this small p is denoted as the probability of success. The probability of success, which we have already seen in binomial distribution. Okay, so P is the probability of success, which we have already seen. This puts in the category of binomial distribution. So when we talk about the differences of mean, so when differences of means are there, it means we have the two populations involved in this. So we have a two population. Before I go to difference of mean, let me put one more term here, that if the sample size is large for the proportion, if your sample size exceed more than 30, then you have to use the standardized normal variate, and the Z formula will become capital P minus mu P divided by standard deviation of P. So this will be the standard normal variate we will use for proportion whenever your sample size exceeds more than 30. For differences of mean, the mean of x1 bar minus x2 bar, because we have two populations, so we will be having two samples definitely. So mu of x1 bar minus x2 bar can be written as mean of population 1 minus mean of population 2. This is the formula. And the standard deviation of difference of two mean, because we're talking on differences of mean and two populations are involved, so two samples will be having. So the standard deviation of difference between two mean will be equal to straightforward formula of square root of sigma 1 square by n1 plus sigma 2 square by n2. So I just need some space. And if your sample size exceeds more than equal to 30, it means if it is and we are also finding the probabilities when the sample size is large, then you have to use the standard normal variate. In place of P, now you will get the mean of x1, here you will get x1 bar minus x2 bar, that is the difference of mean, minus the mean of x1 bar minus x2 bar, and whole divided by, you will get the standard deviation of x1 bar minus x2 bar. This will be the standard normal variate used for differences of mean. Similarly, when you have a difference of proportion, when you have a difference of proportions involved, you will come to know whether you are dealing with the difference of proportions or difference of mean or proportion problem from the statement itself. So in this case, this formula will turn out to be your capital P1 minus capital P2, okay, or we can put in this manner, that is the mean of proportion 1 minus proportion 2 will be same as P minus or P1 minus P2. All right, and the standard deviation of proportion 1 minus proportion 2. As we have seen the formula we have for standard deviation here for single proportion. So as you can see, your mu p was equal to same as small proportion. So this also I can replace with the p minus p. So generally this term will always turn out to be 0, but we will discuss that a bit later. All right, but sigma p1 minus sigma p2 will be what? This will be a square root of pq by n1 minus p1 q1 by n1, and this will be p2 q2 by n2. So don't forget that your small p, which is this portion, is probability of success, and definitely your q will be equal to 1 minus p, which is the probability of failure. So this part we have already seen in binomial distribution. Okay, and if the sample size exceeds more than 30 and we are finding the probability, then your standard normal variate for this will turn out to be similar to this difference of mean only, but only apart from x1 x2 bar the proportions will be involved. So this will be capital P1 minus capital P2. Okay, and this will be minus of mu P1 minus P2, but anyway this term becomes 0 in the problem. We will see that, and whole divided by standard deviation of P1 minus P2. These are the all set of formulas which you have to use to solve the problems. So yesterday I have received some message from the students and about the center limit theorem. So I said that I will repeat about center limit theorem. That guy has, some student has not understand the application of center limit. In very simple words, if I can say that whatever the population you are dealing with, whatever the kind of population you are dealing with, this population can have any type of distribution. This population can have any distribution. So what I mean by any distribution, we have seen some kind of distribution. We have seen uniform distribution. So this population may have uniform distribution pattern. This population may have exponential distribution, or this population may have bimodal form or any form. This population, what kind of distribution it may be, doesn't matter. But ultimately, when you take the sample size large and large, this population this population distribution will get a normal distribution curve whenever you take the sample size large. It does not matter what kind of population you are starting with, what kind of distribution you are dealing with. It anyway turns out to be, whenever you take sample size large and you start plotting the mean of those, that is why the reason in the formula I have always put x bar, and here this will be the mean. So that will get converged to the normal distribution. That is why we use this formula of normal distribution z equal to x bar minus mu of x bar divided by sigma of x bar for mean, and z is equal to p minus mu p by sigma p for proportion, and so on. So this RHS may change according to the proportions or difference of mean or difference of proportions or whatever it may be. But the ultimate idea is that whatever the difference is, whatever the distribution you are dealing with, it ultimately get converged to a normal distribution whenever you take sample size bigger and bigger. All right. So as we have seen in the case that in the distribution of mean, when we're taking the samples, and when from this sample, when you start writing the mean of each pair, okay, so this mean of each pair, which we denote as x bar for time being, which is here, when you start putting these values inside this graph, that graph will always look like normal distribution curve. This is what the idea of central limit theorem. So now let's go back to the problem. So let us see what we have here. So find the probability that in 100 toss of fair coin, between 45% and 55% of the outcomes are head. So they are focusing upon the number of head here. So as you can see, your 45 percentage is involved. So whenever you have percentage involved in this, you're definitely dealing with the proportion of the problem. Okay, so they're not really talking about mean anywhere. So this problem is not in the category of either mean or difference of mean. This problem is in category of proportions. So to answer this question, first I need to have the value of small p, which represent the probability of success. So in this case, probability of success means we are dealing with the probability of one second. Probability of success means here probability of getting head is the success for us. So what is the probability of getting a head in one toss? Anyway, this is the sample size they have given here of 100 toss. But whenever you want to write a value of small p, you always take the value of p from one toss. So what is the probability of getting a head of one toss? So probability of getting head in one toss, one time toss, is equal to, that is implies your small p is equal to half. So always, what are the sample size they will give you? Always write the p value of one toss. So when p is equal to half, then your definitely q also will be half, 50% chance of being occurring. So now you have got the small p value. So from the given data, you have 100 tosses given. So we have n value given as 100 in this case. So sample size is 100. Anyway, they have given as 100 toss. So this 100 toss is equivalent of your sample size. So small n value is 100. So now you can use the formula and calculate what is mu p. So mu p is equal to small proportion p. So we have already got that is half. So just write that as 1 by 2. Next, I need to find the standard deviation of p, which is nothing but the formula we have just now seen, that is pq by n. So we just substitute the value. P and q both are 1 by 2. So 1 by 2 into 1 by 2 becomes 1 by 2 whole square divided by 100. So this will be 0.5 whole square by 100 of square root. So how much you will get this? 0.5 square by 100 and square root of answer. So I'm getting this value as 0.05. So now this step is over. We have to find mean of proportion. We have done that. We also need the value of standard deviation of proportion, and that also we have calculated. So I will just write sigma p is equal to 0.05 here. Now next part is they want to find us the probability that in 100 toss of fair coin, between 45% and 55% of the outcomes are head. So definitely your number of sample size is more than 30 and you are finding the probability. So definitely you have to go for the standard normal variate. So the standard normal variate Z involved for proportion, as we have spoken, this will be capital P minus mu P divided by sigma P. Now why I have put here capital P? This capital P represent the probability between 45% to 55%. So basically what we are finding here, we need to find the probability of your proportion, which is a capital P, lies between 0.45 to 0.55. This value we need to find. And we know that by using the center limit theorem, because your sample size is more than 30, so this particular distribution will definitely fall in the category of normal distribution. That is the reason I have taken the standard normal variate in this case. All right. So what you have to do, you have to now substitute p-value as 0.05 in z and find the value of z. You have to substitute p-value as 0.55 here and find the value of z. So this portion will now get converted as we have done in the normal distribution. This p proportion will now get converted to z value. So this z value I need to find. So how to find the z value? Just substitute the capital P value in Z here. So what will happen? So if your capital P is equal to 0.45, let's say, so when you substitute 0.45 here, your Z becomes 0.45 minus, what is the mu P value? 1 by 2, which is 0.5 whole divided by sigma P. Sigma P we have calculated 0.05. So just quickly calculate this portion. 0.45 minus 0.5 divided by 0.05. One second. 0.45 minus 0.5 divided by 0.05. So I'm getting the value as minus 1. So this portion I'll just rub this part here. So now you can see when z is equal to 0.45, I'm getting the value as minus 1 here. Now what is the value of z when it is 0.55? So if capital P becomes 0.55, so z becomes 0.55 minus 0.5 divided by 0.05. So when you quickly calculate this part, I will get exactly 1. So the probability of finding this is actually equivalent of finding probability of this portion, that is in terms of z, because this is normal distribution. So now we can calculate the probability of this portion. So to answer this particular question, you have to first plot and see which area you are dealing with. So when you just roughly draw that, because I want to write the value. So here it is minus 1, here it is 1. All right. So z lies between minus 1 and minus 1. So this particular area probability I want to find. So how you will find the area of this particular portion? So you have to just add this part, which is your area of 1. One second. And you have to also add this particular portion, which is also an area of 1. Negative, I'm not writing negative 1 here. Negative 1 is just shows the left hand side or right hand side. Just give the direction. Negative means left hand side, positive means right hand side. But whenever you want to write the area, it will be 1 only. So this plus this we have to write, or we can just simply write that as 2 times of area of 1. Anything is fine because both the values are same. So when both the values are same, just write the value area of 1. So area of 1 you can calculate from the calc, as I've told you. So we have to go to the mode and distribution and q value of 1. So this I'm getting as 2 into 0.34134. So when you multiply with 2, your answer will be 0.6826. So this is the probability we are looking for. So 0.6826 is the probability that in 100 toss, the fair coin between 45% to 50% of the outcomes are head. So 68.26% approximately is the probability, right? So the same thing I have already mentioned here. So we have treat 100 toss as a sample size n equal to 100. So P probability of getting a head in one toss is P1 by 2. So the mean and standard deviation is this formula, straightforward. So small p is 1 by 2, just substitute it here. And sigma p you can calculate by this formula. Q is nothing but half because 1 minus p is the failure. So the corresponding z will be p minus this. Always remember that this will be your capital P. This is your capital P. And this capital P we will always take from the problem. This deal with the probability here. Okay. So we need to find the probability of this portion. So for p is equal to 0.5, you will get z equal to -1. For p is equal to 0.5, you will get z equal to 1. And this you have to calculate from this set. So ultimately, you will get this portion. So this is nothing but 2 times of area of 1. So 6826 is the answer. Okay. If any doubt anywhere in between, please put in the comment section or raise your hand. Okay. Fine. Let's go to the next question. Out of 1000 sample of 200 children each, find that less than 40% are boys. Okay, between 40% and 60% are boys, and 55% or more are girls. It's a very simple problem. So out of 1000 sample of 200 children each. So first question for you is that what is the n value you will take? Either you will take n value as 1000 or you will take n value, that is sample size, as 200. Which you will take? This is the only confusion part here. So first you tell me what is your n value here. Whether you take 1000 or 200 children. Tell me. Vadiraj telling 1000. Okay. No, actually in this case your n value will be 200. Your sample size will be 200. Now what is the use of this 1000 samples? Okay. See, when you find the probabilities of all these each cases, each probability, whenever what are the answer we will get, that we will multiply with 1000 and we will see how many samples we will get out of 1000. But your n value is 200 only. The sample we are testing the probability is out of 200 children only. But out in that 1000, again they have taken sample of 200. So we will find the probability with n 200 and then we'll multiply with that 1000 so that we will get samples out of 1000. This is a use of 1000. So here's a small confusion they have created, but take n value as 200 only in this case. Anyway, so again this is all percentage form, so this lies in the category of proportion. So we have to find the value of, we know the formula that your mu p is equal to proportion p, and your sigma p is the formula we have square root of pq by n. I need the value of p here. So you have only two possible cases, that is boys or girls. So what I will do now, let p is the proportion, I'm denoting p is the proportion for boys. Okay, I'm taking the p as the proportion of boys. You can take even for girls also, doesn't matter. So I will be focusing on p is the proportion for boys. So what is the probability of getting a boy or a girl? You have only two options, either boy or girl. So probability of each will be 1 by 2 or 1 by 2. Okay, so proportion of getting boy is half. because you only two possible options, either boy you will get or girl you will get. So proportion will be 1 by 2. So just substitute that in mu p. So that is equal to your half. If p is half, then q is also 1 minus half, which is equal to 1 by 2. So your sigma p will become square root of 1 by 2 whole square divided by 200. This is complete square root. So if you just quickly calculate this part, 0.5 whole square by 200 and square root of answer. So this I'm getting as 0.03535. So I can just round this figure. I will just write 54. So this is the value we have got. So now we have to answer all this question. So we are finding the probabilities. So for that you introduce your standard normal variate. So this will be your capital P minus mu P divided by sigma P. Okay, we all discuss what is Z and why we have to include Z. So now let us answer the first question. Less than 40% are boys. So we have to find the probability that your proportion of the boy is less than 0.4. This we have to find. So if P becomes exactly 0.4, then what is the Z value? So Z value will become 0.4. In place of P, you have to put 0.4 minus mu P is half, which is 0.5 divided by sigma P is 0.0354. So if we just quickly calculate this portion, I will get minus 2.82. So this particular probability will now get converted to probability of Z less than minus 2.82. So how to find this? You have to again plot and check which area we are looking for. So minus 2.82 will be here. So this will be 2.82. Minus is just the direction, so I will not put minus here. So anyway, just put the minus. So less than 2.82 means which value I'm dealing with? This particular value I want. Less than. So how to find this particular value? So this area is 0.5. So 0.5 minus of this particular area you have to do. So minus area of 2.82 you have to do. So when you calculate this portion, 0.5 minus the value of 2.82, again you have to calculate from calculator. So distribution Q of 2.82. So this value I'm getting here is 0.4976. So when you subtract this from 0.5, I'm getting 2.4 to the 10 to the power minus 3. So I will write this as 0.0024. So this is the probability I have got here. But we have to find that out of 1000 samples, how many samples will have less than 40% boys? So just remember this value. I will just rub this portion. So we have got the probability of Z less than 0.4 as 0.0024. So out of 1000 sample, we will put in this way, out of 1000 sample, the number of boys, not number of boys, the percentage of boys. The percentage of boys, which is 40%, implies 1000 into 0.0024, which is coming approximately 2.4, or I will just write in general round figure to 2. So only out of 1000 sample, only 2 samples contains 40% of boys. This is what it means. Out of 1000 sample, only 2 samples contains 40% of boys. Anyway, let's go back to the second portion. Now we have to find the probability of your proportion lie between 0.4 and 0.6. So here we have Z is equal to P minus mu P by sigma P. So when P is equal to 0.4, we have already got the value in previous case. So this was minus 2.82, we have already get. Now we will find when P is equal to 0.6. So if P is equal to 0.6, your Z becomes 0.6 minus 0.5 divided by what is sigma P, something around 0.0354. So if we just quickly calculate that part, just change the P value. Okay, so this I'm getting 2.82. So both value are same, just the directions are different. So this will be straightforward, 2 times of area, 2.82. So this will be 2 into, we already seen the value of 2.82 earlier. So this value is 0.4974. So when you multiply 2 times of this, you will get 0.9948. So out of 1000 sample, implies you have to multiply this with 1000, which comes around 994.8, or approximately I'll write 995. So out of 1000 sample, 995 samples have boys between 40% and 60%. 995 samples have boys between 40% to 60% out of 1000 sample. This portion. All right. So I hope this part is clear. Now third is 55% or more are girls. Okay. Now in this case they are talking about the girls, but initially if you remember I have taken the P as the proportion for number of a percentage of boys. Put in this manner. We are focusing on boys only. So the percentage of boys only we have dealing with. So how to find the probability of 55% or more are girls? So probability of 55% or more are girls is equivalent to find that probability of 45%, less than 45% I can put, less than 45% are boys, because you have already taken proportion as percentage of boys, so we have to only focus on the number of boys here. So even though if they are asking about the number of girls, which is 55% or more, so 55% or more is equivalent to less than 45%. So we will find this portion. This portion will automatically give me the answer of 55% or more are girls. So I will find that your proportion of boys less than 0.45 I will find. So what will be your Z value here? So your Z value will be 0.45 minus 0.5 divided by 0.0354. So if you calculate this portion, I will get minus 1.41. So this implies the probability of Z less than minus 1.41 equal to. So once again you plot and check. Minus 1.41 lies somewhere here. You want less than value, so this particular portion. So once again 0.5 minus of this area, which is nothing but area of 1.41. 0.5 minus this value you have to calculate from normal table or from the calculator. So this value we will get 0.4192, and this probability is coming around 0.0808. So when you multiply this with 1000, you will get approximately 80.8, or I can say 81. So 81 samples. 81 samples. So out of 1000, 81 samples have 55% or more girls. So that's it for this problem. If any doubt in this problem, please let me know. So I have already mentioned all the portions here. We can just have a quick look into that. So I already put the answer. 1948, so 995. I think here we have got 0.0024. We have got the answer, but I've written here 0.26. You check the calculation. I think I have done some mistake. Maybe some decimal mistake might be happening here. So you check it out. So earlier we got 2, but here I'm getting 2.6. So I've taken as 3. So that kind of error is possible. Doesn't matter. So third question you can see here, finding the probability of 55% or more are girls is equivalent to find probability of less than 45% are boys. Because initially itself, we have taken the proportion of boys in a sample. Because majority of the questions are on boys, so that is why I have fixed this as boys. So whenever you have to find probability of girls, convert this to number of boys, and then you can find the probability. Okay. So that's it. So now let us see this problem. This problem comes in the category of differences of mean. Okay. Right, I just put a line. Okay. The electric light bulbs of manufacturer A. There are two types of manufacturer for light bulbs, that is A and B, two manufacturer. So this electric light bulb have a mean life of 1300 hours for manufacturer A with standard deviation of 120 hours, and for manufacturer B or company B, the mean life of the bulb is only 1200 hours and standard deviation is 90 hours. So this data is given. So if a random sample of 150 bulb each, means N1 and N2 both are 150 sample size, are tested, then we have to find what is the probability that brand A bulb have mean life which is at least 80 hours more than brand B bulb. So these problems will lie in the category of difference of mean, because here two means are given. Okay, so I have taken the notation as X bar A, and X bar B denotes the mean life of sample of brand A and B respectively. So by the formula of difference of means, this is the formula: mu of X A bar minus X B bar is equal to mu1 minus mu2. So this value already they have given, which is 1300 minus 1200 hours. So you will get 100 hours. So standard deviation also we have the formula, which is sigma 1 square plus sigma 2 square. This will be for brand B bulb. So sigma square means but they have given standard deviation. So we have to just square this up. So we have taken 120 square by 150. Both N1 and N2 has same sample. So 150 is for both of each brand. So this is also 150. This is also 150. So 120 square by 150 plus brand B bulb have standard deviation of 90. So this will be 90 square by 150. So when you calculate, you will get 12.247. Now we have to find the probability that brand A bulb have mean life, which is at least 80 hours more than brand B bulb. So you can see here, I have written in this form that your brand A bulb, the mean of brand A bulb is at least 80 hours than brand B bulb. So this portion I have taken here, but this part I just written for you to make understand the statement. So when you take this side becomes XA minus XB bar. So definitely you will get the difference of mean here should be greater than equal to 80. So this is what we have to find in this case. So what the standard normal variate involved for this? This is the standard normal variate I have just now told beginningly. So in this case, you have to take XA minus XB bar as 80. You already have the mu value as 100. You have standard deviation value as 12.247. Just substitute that here. So this value is 100. This value is 12.247. So if you take XA minus XB equal to 80, you will get Z equal to minus 1.63. So Z greater than minus 1.63 they are asking. So what area they are asking us? Let us check. So minus 1.63 will be here. So greater than or equal to. So greater than or equal to means this complete area you have to find. So because it's a normal distribution curve, you know that the area under the curve is 1. So left hand side is 50%, this side is 50%. So you want to find this complete area, it is greater than here. So it means what? This area will be complete 0.5 plus this particular area, which is area of 1.63. So when you add these two, you will get the complete area of the dashboard. So I've written here, this will be 0.5 plus area of 1.63. So this value you have to calculate from normal table or calculator. So when you calculate area of 1.63, you will get 0.445. And when you add this, you will get the probability as 0.945. So this is the probability of difference of brand A bulb and brand B bulb. Or we can say that your brand A bulb last at least, or we can say brand A bulb has mean life of at least 80 hours more than brand B bulb is 94.5% chance that brand A bulb will run longer than 80 hours more than the brand B bulb. This is what it indicates. So anyway, let us see the last problem of the today. So what is the time here? 9:23, almost we are about to finish. So now here we have two friends A and B who plays the game of head and tail. Each toss a coin 50 times. So your sample size for A and sample size for B both is 50. So A will win if he gets 3 or more head than B. All right. Otherwise B wins. So find the probability that A win the game. So how are we going to answer this sort of question? So This question lies in the category of proportion. Okay, but here you have two players A and B involved. So definitely this problem will lie in the category of difference of proportion. So to answer this question, we will take some notations that let P of A and proportion of B. So this denotes the proportion of, uh, they are focusing upon head only. So I will take head, denotes the proportion of head obtained by player A and player B. So P of A and P of E is denotes the proportion of heads obtained by player A and player B. Okay, so what will be the probability of success of getting one head? Will be half. This is nothing but getting one head, getting head in one toss, getting head in one toss. Whenever you have to write the proportion small p value, always write from one toss. So probability of getting head will be 1 by 2. Okay, so by the formula of difference of proportion, we have P of A minus P of B is equal to P minus P. So both is 1 by 2. So I have already told that this term always turns out to be 0. But what about the standard deviation of PA minus PB? That will be a square root of PQ by NA plus PQ by NB. So this implies this is also 1 by 2, this is also 1 by 2. So this will be half whole square by 50 because they are tossing 50 each. This is also 1 by 2 whole square by 50. So when we calculate this quotient, we will get 0.1 approximately. So we have to find the probability that A will win the game. So the probability that A will win the game, so I will take the difference of both, and that should be greater than 3 by 50. He has to get 3 head out of 50. Okay, so if I put in another words, I can say a probability of A will win when he get 3 by 50 heads then B. So I have taken this portion here. So either I will put greater than equal to, or this doesn't matter. So to answer this question, again you have to standardized normal variate you have to use. So you have the formula of capital PA minus capital PB minus mu of PA minus PB whole divided by standard deviation of PA minus PB. So if your Z value is 3 by 50, sorry, if your PA minus PB is equal to 3 by 50, or in decimal how much? This is 0.06, then what is the Z value you will get here? This will be 0.06 minus 0. This value is anyway 0 divided by 0.1. So divided by 0.1, I'm getting 0.6. So you will get Z value as 0.6. Let's rub this portion here. Right. So this implies the probability of Z greater than equal to 0.06. So which area you are finding here? Just plot it and check. 0.06 positive, so this will be here. So greater than means this value you are finding. So this will be 0.5 minus of this area. This will be 0.5 minus area of 0.06. So this will be 0.5 minus this value you can calculate from normal table or calculator. So from calci I am getting this value as 0.2258, which is equal to 0.224. I'm getting 0.2742 or approximately 27.42% chance that team player A will win the game if he get 3 out of 50 head. Okay. So I have given the answer. You can just quickly go through that. So that's all. These are some assignments I will post in the drive, but you can take the snapshot now. This question I have already given you assignment in the first class. Second question I have included here. Just try these questions. If you get the answer, okay. Otherwise, we'll discuss this part. So now we are done with the sampling distribution. Next class we will discuss about maximum likelihood estimator. Likelihood estimator. All right. So if anyone has any sort of doubts, you can please unmute yourself and ask the doubts.